Okay, we'll wait a second while all the attendees come into the webinar. Okay, well, hello and welcome to the webinar. My name is Josh McDaniel and I work with the Wildland Fire Lessons Learned Center. I'll be introducing the presenters for today and moderating the question and answer session later on. I want to point out, first off, that the webinar series is sponsored by 3 organizations. First off, there's the International Association of Wildland Fire, the Joint Fire Science Program, and the Wildland Fire Lessons Learned Center. And this webinar that we're presenting today represents the kickoff in a series within the series focused on smoke science. For the next several months, we'll be hosting webinars focusing on research conducted under the Joint Fire Science Program's Smoke Science Plan. Smoke and smoke management will likely increase in priority for everyone in the wildland fire community over the coming years due to air quality regulations and increasing urban interface and potential climate change impacts. And JFSP is funding research to help do a variety of tests, validate smoke models and projections, improve understanding of emissions, dispersion, and chemistry, increase understanding of human health issues related to smoke, and then also looking at community tolerance and attitudes towards fire and fuels treatments and smoke. The JFSP Smoke Science Plan has 4 integrated research themes shown here on the screen. There's the emissions inventory research, fire and smoke model validation, looking at smoke and human populations, and then climate change impacts in smoke. And we'll be, over the next coming months, there will be presenters covering each of these 4 different themes. So check back with us and look at the schedule, and I'll show you the ones that are scheduled so far in just a moment. And we can, and it should be a very interesting series. So today, Roger Ottmar and Susan Pritchard from the Pacific Wildland Fire Sciences Lab are going to start off the smoke webinars. But first, I'll show you the upcoming webinars. So we have on next month after the holidays, Sean Urbanski is going to be speaking on January 14th on a data set for the evaluation of smoke models, emissions, plume rise, and dispersion. And February 19th, Young Liu is going to be presenting on evaluation and improvement of smoke plume rise models. And then on April 9th, Warren Heilman will be presenting on predicting local smoke dispersion during low-intensity wildland fires in forested environments. Okay. So if you're on the Lessons Learned Center email list, you should receive an announcement for each of these webinars with a link to register. But you can also find the list of the schedule and the links to register on the Advances in Fire Practice homepage. AFP is sort of a sub-site within the Wildland Fire Lessons Learned Center's large and growing website complex. But under Resources, you can see it on the screen there. Click on Resources and it'll take you to the Advances in Fire Practice page, and then there's the webinar schedule as well. Okay, so I want to also just real quick want to plug the Lessons Learned Center's new website. We just went through a major web platform change and redesign of the website, and if you go to the home page and start working your way through it, there's some really cool stuff in there and a growing amount of resources, so I encourage you to check it out. Okay, so on to today's webinar. First, I want to talk about questions. If you have questions, type them into your questions box down below in your control panel. Should be at the bottom of your control panel. We will have a Q&A session at the end of the presentation. So at the end, we will read through the questions and the presenters will respond verbally to them. So we'll work our way down the queue. So the earlier you get your questions in, the better chance you have of us actually being able to get to that question. Okay. Also, the webinar is being recorded, and the recording will be available about an hour after the webinar is complete, and you can find the link to that here on the Advances in Fire Practice page shown on your screen, or you can email me, and I believe my email should be in some of the communications you've gotten about the webinar, and I'll send you the link, and you can pass that on to whoever you think might be interested. So now I'm going to hand it over to Roger Ottmar and Susan Pritchard. They're going to introduce themselves, and then they'll take it from there and do the presentation. So welcome, Roger and Susan.
Thank you. Yeah, are you going to release the screen to me?
Sure. Yep.
Well, thank you very much. I really appreciate the opportunity to discuss this very important project that was funded by the Joint Fire Science Program entitled Validation of Fuel Consumption Models for Smoke Management Planning in the Eastern United States. I'm Roger Ottmar. I'm a research forester with the Pacific Wildland Fire Sciences Laboratory located in Seattle. It's part of the U.S. Forest Service Pacific Northwest Research Station. And my work over the past 30 to 32 years has been dealing with fuels and fuel consumption, along with looking at smoke exposure of firefighters. I'd like to also introduce my colleague, Susan Pritchard, who is a scientist with the University of Washington. She is the program manager for the software system called Consume, also the software system called the Fuel Characteristic Classification System. Now this webinar presentation, we're going to first of all take a look at project overview. And then we'll look at the data that was collected during this project. Finally, we'll talk a little bit about some of the data sets that have come out of this project. Then we'll discuss the deliverables and management implications, followed by Consume and the program called the First Order Fire Effects Model Evaluation. Susan Pritchard will be taking over the webinar at that point. Now this project has several objectives. The first objective was to measure pre and post fire fuels and environmental variables on prescribed fires, specifically in the eastern part of the United States. And this data was then going to be put together to actually be able to evaluate fuel consumption models. The two models that we wanted to really evaluate included Consume, which is developed by the Pacific Wildland Fire Sciences Laboratory teams, along with the First Order Fire Effects Model, which is developed from the Missoula Fire Lab. And after the evaluation, we're going to see if we could possibly assist in modifying Consume to better be able to predict for these eastern U.S. prescribed fires. And then finally, we wanted to provide both an eastern and a western U.S. independent fuels consumption data set for future modifications and future evaluation of fire tools. Now this project wouldn't have been nearly as efficient. We wouldn't have been able to collect as much information if it wasn't for the leveraging. And the first thing I want to do is thank the Joint Fire Science for funding this particular project. And then secondly, they funded several other projects that we were able to piggyback off of that gave us a larger data set to use for evaluation. One of those projects was the Season of Burning and Fuel Dynamics, which was concentrated down in the southeast part of the United States. We also were able to use the RX Cadre projects in 2008-2011 and methodologies and also information that we collected from those burns. And then we used all of the burns that we actually measured was in support by the U.S. Forest Service and Fish and Wildlife Service, along with the National Park Service, the state of Florida, the state of Ohio, and Jackson Guard U.S. Air Force. And if it wasn't for the help of those folks, we wouldn't even have gotten off at the starting blocks. Last of all, I'd be kind of remiss if I didn't mention the National Fire Plan that also helped fund a portion of this project. Now, what about the problem? Well, first of all, fuel consumption is one of the critical variables when you start looking at smoke management in the eastern U.S. If you look at the right side there and see this flow diagram, you can see that fuel consumed is an important part if you're starting to estimate emissions and then look at impacts downwind. And some of the earlier work that has been done by Janice Peterson showed that fuel consumption actually contributed about 30% to the variation that occurs when you go to try to estimate emissions. The other thing that is a big problem is that the Consume and Folsom are the two major systems that are relied upon in the eastern United States to predict fuel consumption. And the problem is that they haven't been evaluated. So we don't really know how well they work in the eastern U.S. The other thing is that Consume uses Western equations for eastern mixed hardwood fuel beds. And we didn't have an idea how well that worked, and we did that because there was no good data out there to be able to modify our equations or adapt them to the mixed hardwoods. And at the many workshops, the manager said, you know, we're not sure how well these consumption models really work in certain fuel bed components such as the duff. And we listened to the folks that, yeah, we need to do an evaluation. Both systems, like I said before, have not been thoroughly evaluated. And there's really a limited data set out there for evaluation, and especially for the mixed hardwoods. So those kind of lay out the problems that we had to work with this particular project. Now, as far as the background goes, fuel consumption is the amount of biomass consumed during fire. And you've got to remember that it's all the biomass. It's not just the biomass that contributes to fire behavior. It's not just the fine woody fuels and the litter and the grass and the shrubs. It also includes the large woody debris and the duff material, which can smolder for a considerable length of time and has caused some real smoke impacts. And also, the fuel consumption is a key requirement for many decision support systems. The decision support systems for smoke management, for instance, like Blue Sky Modeling Framework, has built-in fuel consumption models. The fire and fuels management systems, such as the IFTDIS, which is another system that's supported by the Joint Fire Science Program, has fuel consumption models built into it. And we also have systems that deal with ecology, wildlife, and carbon accounting, and they also have to have fuel consumption modeling. And again, I want to mention that Consume and the First Order Fire Effects Model are the two major systems that currently in the U.S. are used to predict fuel consumption. Now, what about our project approach? Well, first of all, we needed to locate a minimum of 20 southern pine and mixed hardwood sites in the U.S. to build this data set that would allow us to evaluate these two fuel consumption systems. We wanted to measure the pre- and post-fire fuels and environmental variables. And at a minimum, what we wanted to do is make sure that we accounted for the variables that are required as inputs to Consume and Folsom. Thirdly, we wanted to evaluate those two systems using this data set. And then we wanted to do kind of complete a thorough literature review and compile another independent fuel consumption data set from this previous work. So we had something to do some additional testing with and for other modelers and scientists to use in testing their systems. Finally, we wanted to make sure that we could get this information out very quickly to the managers and also to scientists. And so we have been putting on workshops describing this project along with a publication in the Canadian Journal of Forest Research. So the project and the results of this project, who is it important to? We feel it's important to both fuel and fire planners, fire and smoke modelers, firefighters, fire ecologists, wildlife managers, and smoke and carbon regulators, and there's probably a myriad of other folks that this data will become very important to. So let's take a look at the methods for collecting the data, and this was for the development of this fuel consumption data set for evaluation. And the first thing is that we went out and contacted many land managers and we're able to select 29 units that we were going to measure the fuel consumption on throughout the eastern United States, and we collected the data during the years of 2009 and 2010. We zeroed in on sites that had longleaf and loblolly pine, along with some sites that had pond pine. We also zeroed in on the mixed hardwoods in the central and the eastern part of the United States. So where are these units located? Well, there was 5 units located at Eglin Air Force Base for longleaf and loblolly pine. There's an additional 8 units located in the Apalachicola National Forest and 2 at St. Mark's National Wildlife Refuge. And we had 2 pond pine sites at Pumpkin Hill Creek Preserve in the state park, or 3 sites on the eastern side of Florida. We also had 3 sites at Mammoth Cave National Park for the mixed hardwoods, 4 additional mixed hardwood sites at the Daniel Boone National Forest, 2 at George Washington Jefferson National Forest, and 2 at Tar Hollow State Park. Now, the variables that we measured had to be the variables that were important to running both Consume and Fulcrum so we could do an evaluation. However, we knew that these data had to be very, very robust because we knew that there's going to be other models out there or future models that were going to require additional data. So we collected more than just what was required by the model inputs. So we looked at the shrub loading, height, percent cover, grass and forb loading, height, percent cover, woody biomass loading by size class, litter depth and loading, duff depth and loading, and we took photos of each of the plot areas. The day of burn, we collected fuel moisture samples for the shrub, grass, the woody fuels by size class, litter and duff, and we also collected weather parameters including temperature, relative humidity, wind, and days since rain. Post-burn, we zeroed in on the biomass loading remaining by category, along with percent black, which is input for Consume, and also collected photos of the plots. Now, how did we do this? Well, first of all, from a lot of the work we've done previously, we felt we needed a total of 22 plots to be systematically positioned in each unit to kind of represent that particular unit and the fuel beds. And within each one of those consumption plots, we ran a series of line intersect inventories along with a series of forest floor pins to look at duff and litter consumption, along with clip plots to assess the vegetation of both shrubs and grass. With the pre-fire fuels, with the 0 to 3 inch, we used the woody line intersect inventory and used the count to determine mass. For the shrubs and grasses, we used clip plots to determine mass. For the 3+ woody material, we actually wrapped wires around logs to get a diameter to determine mass. And for the litter and duff, we used forest floor pins to determine depth and then calculated using bulk density the loading. And we also looked at percent cover with a visual estimate. Fuel conditions and weather, we collected 10 to 20 fuel moisture samples before each fire for the shrubs, grass, the woody, litter, and duff. The weather, we collected temperature, relative humidity, and wind speed and wind direction with handheld instruments at the site. And then we collected days since rain information from the closest raw station. Post-fire was very, very similar. We used the same line intersect inventory to look at the 0 to 3 inch woody material. The shrubs and grasses, we had to randomly select another clip plot that was very close to the original clip plot to determine the shrub and grass loading. The 3+ woody, we used the wire log to determine diameter reduction and thus consumption. And then we used the forest floor pins to look at depth and loading remaining, along with a visual estimate of percent cover and percent black. So taking a look at the results, we designed the system to actually take that data and look at a unit average. So those 22 plots, all the information was averaged together to produce a unit average. We covered a range of fuel bed types and topography and environmental conditions. We also burned these under burn plan prescriptions, meaning that they were your typical burn situation. We wanted to do that because we wanted to compare consume and fulcrum with your typical burn situation. So we didn't look at these extreme events like very, very dry or windy conditions or under very, very wet condition when you get a real mosaic burn. So let's take a look at some of the fuel loading information, and I broke it down into both the pine and hardwoods. Now the first thing that you'll notice that's very evident is that in the pines the fuels range from 2.1 to 9.3 tons per acre, whereas in the hardwoods they range from 10.2 to 34.4 tons per acre. First of all, that shows you that there's a heck of a lot less fuel in the pine sites than in the hardwood sites, and that's mainly because the pine sites were burned every 1 to 4 years, so a lot of that fuels have been consumed over the years, whereas in the hardwood sites they were burned less often and there's a lot more fuels out there. Also, when you start looking at this, you will see that in the pine the majority of the fuels were concentrated in the shrub fuel bed component along with the litter and practically no duff. And some of these did have some large woody fuel component, whereas in the hardwoods you had the majority of your biomass was in the 1,000-hour plus material along with the litter and the duff. So moving on to the fuel moisture contents that we collected just prior to the burning. The fuel moisture ranged from 22 to 61% in the grass fuel bed components in the pine site, and in the hardwood site there was hardly any grass except for on one unit, and it was at 7.3%. The fuel moisture for the woody 1 hour ranged from 8 to 27%, and in the hardwoods range from 8% to 39%. So a very, very similar range in the woody 1 hour fuel between the pine versus the hardwood. Now with the fuel moisture for the 1,000 hour, we didn't have a lot of large logs in many of the fuels in the pine units. However, the fuel moistures that we did collect where there were logs range from 66% to 140%, and then with the hardwoods, which all units had logs, range from 8% to about 82%. In the litter, we had pine that ranged from 6% to 35%, and the hardwood ranged from 6% to 48%. So a very, very similar range of fuel moisture between those two types of fuel beds. Now you may wonder what's going on right here. Well, we didn't get to the units soon enough before they burned, and so we weren't able to collect litter in those fuel moisture contents in those particular units. So let's take a look at fuel consumption. And first of all, you'll see that the ranges of the fuel consumption in the pine was from 0.7 to 5.3. There was a similar range in the hardwood of 2.2 versus 6.7. So the fuel consumption was very similar. However, you have to remember that we started out with a lot more fuel to begin with in the hardwood than in the pine, so those percentages of consumption are going to be considerably different, and I'll show that in the next screen in a minute. But I also want to zero in on where a lot of this fuel consumption is occurring, what fuel bed component. And in the pine, you can see that it was largely occurring in the shrubs and in the litter, whereas in the hardwoods, it was occurring in the large woody fuels, the litter, and the duff. So there is a difference on which of these fuel bed components are consuming in those two different fuel bed types. Finally, I want to talk about the total fuel consumption, total fuel and consumption in the pine types. And you can see that looking at the range of consumption, it's ranging from 20% to 75%. Now, when you compare that with the hardwood, you can see that that percent consumption is considerably different. It ranges from 15 to 39%. And that's because there was a heck of a lot more fuel to start with, and percentage-wise, they had a lot less consumption in the hardwoods as compared to percent consumption in the pine. Now, this data has gone into the consumption data sets that I spoke about earlier. And I first of all want to look at the first data set, which is what we call the FARA data sets, and that's the name of our team, the Fire Environmental Research Applications. And this is being written up by Susan Pritchard in prep. And there's a total of 86 units at this point. And that includes these units I just got done talking about, along with units that we have done fuel consumption work on in the past. We also did a literature search and found that Clinton and Colex and Lukes and Schroll and Waldrop and Sullivan and Swift also had some consumption information. However, it wasn't quite as robust as our information we collected from our team, but we put it together in the repository. We also decided to pull together some work from Alaska that our team did, funded by the Joint Fire Science, along with some other western sites for ponderosa pine and sagebrush that was also funded by the Joint Fire Science. So this repository will have a total of 159 units that are going to be accessible by anybody to be able to look and use that to assess their models. As far as our deliverables for the project itself, we wanted to zero in and talk with managers to show them our results, and we've done that with a series of workshops and trainings at RX410, along with workshops at Itchaway, Georgia, and Savannah, and one at Kinston, North Carolina. We have done a lot of different consultations with managers in regards to specifically consume. We have a publication that's been submitted to the Canadian Journal of Forest Research on the evaluation of consume and fulfum. We've got a website that's periodically updated about the project. And finally, we have a series of data sets and databases that are located in the smoke emissions model intercomparison project repository for anybody to look at. As far as the next steps, as I mentioned before, we did not concentrate on any extreme situations when it came to prescribed burning. And so if you're looking at heavy fuel loadings, more complex fuel beds, extreme burning conditions either on the dry or wet end or long-term smoldering, there isn't that much data out there, and our next steps would have to include that. Also, we'd like to do a similar project, or think there should be a similar project done for the West. Finally, let's take a look at management implications. First of all, this is going to provide this evaluation data set for many different scientists and for managers to look at the different models and how well they're predicting. We have the fuel consumption comparison between consume and fulfum, and that has shown us that those models can be improved. So we as modelers need to get our act together and start improving on that. And we have been improving on consume 4.1 based on this study, with looking at improving our fuel consumption equations and improving some of the different consumption equations for specific fuel bed components and changing heat release conversion problems and emission factors. Finally, I have to get on my soapbox a little bit about consume and fulfum. These are the two major consumption systems that are out there that people use. These systems they're not in competition at all. They were basically developed to meet different objectives. Consume was developed specifically to look at smoke management and ways in which you can do a burn and reduce the total amount of emissions. FOFM also has that capability, but also was looking at other fire effects such as tree mortality and soil heating. And as scientists, this project is so important to us because it allows us to actually look at both of these equations in a completely unbiased framework to see exactly where these models can be improved. And so that's kind of a segue into Susan Pritchard's discussion, where she'll be actually talking about the evaluation of consume and FOFM using this fuel consumption data set. So, Susan, I'll pass it over to you.
Sounds good. Hi, everyone. My name is Susan Prichard, and I'm going to be taking over mostly discussing an evaluation of consume and FOFM using this important validation data set. One of the things that I had a nice perspective on is that Roger had asked me to compile available test data from the literature. And it was quickly apparent to me that although there was a number of really great studies out there, the different sampling methodologies meant that the data sets weren't consistent enough to really be used as a coherent test data set. With this project, we were able to compile a large number of very similar fuel consumption data sources from burn units and be able to use them as that cohesive, reliable validation data set. So our objectives in this was to assess both the consume and FOFM models for their prediction uncertainties, any over or under prediction biases that individual equations might have, and then application limits specifically to southern pine forests and mixed hardwood forests in the eastern United States. We also wanted to use this validation study to inform and inspire development of new predictive models. This map will look somewhat familiar to you. So we actually compiled, thanks to supplementary data from Clint Wright and Jim Cronin from an earlier JFSP project. We had a total of 43 southern pine sites, and then we had 11 mixed hardwood sites, and that was from this current project. All right, I'm going to give you a little background on consume and FOFM. We call them both models, but actually they are applications that house individual or a lot of different individual models. So I'll start with consume. Right now we're working with consume 4.1, which is a new calculator. It has some revisions to the 3.0 version. So in terms of the natural fuel consumption equations that we used in consume, they're actually all empirical equations developed from previous consumption studies. So for instance, for the shrubs, 1,000-hour wood, litter, and duff, they're simple linear regression models with a basic form that I've represented in this table. Similarly, consume predicts herbaceous 1-hour, 10-hour, and 100-hour wood based on models, but in those models, only the pre-burn loading was a significant predictor variable. That's why I'm showing percentages. So simply, consume predicts that 92% of herbaceous or grasses and herb material will burn in a prescribed burn. It assumes 100% wood and then 86.5% of 10-hour wood and 40% of 100-hour wood. These are equations specific to the Southeastern United States. For FOFM, both the shrub and duff layer consumption are empirical regression equations. And then FOFM makes an assumption that 100% of herbaceous fuels and 100% of litter fuels will burn in a successful prescribed burn. So those are pretty reasonable assumptions. And then it uses a physics-based process model called Burnup to estimate 1, 10, 100, and 1,000-hour wood consumption. All right, so our questions were, Really simple. Our consume and FOFM predictions statistically equivalent to measured fuel consumption. And then within that, I wanted to give a little review of some of the ways that we could answer that question. So traditionally, we might use standard goodness of fit. Look at simple plots of measured versus predicted consumption and see how well they fit to a linear regression model. So that's one approach. Another one is what I'm going to introduce is called regions of indifference, which is a way to measure model uncertainty. And then the third is to really look at over and under prediction bias in these individual models. So I'll start out with just a goodness of fit example. So here we actually have some results for consume predictions in a red circle and FOFM predictions in a black circle for shrub and herbaceous components. So predicted values are on the y-axis and measured values on the x-axis. And you'll see that there are really tight correspondence between both. And indeed, we do have really good R-squared values, so high goodness of fit between these models. So that would be one way to evaluate models, although as we moved into evaluating the models, there were some shortcomings to this approach. Namely, a simple R-squared doesn't give you a sense for over and under prediction bias, for example. So now I'll move into the most complicated description that I have for this talk, which is this idea of regions of indifference. So we calculated based on paired t-tests of model residuals this region of indifference. So these windows where modeled values are statistically equivalent to measured values. So over in my left example here, we have a very narrow region of indifference represented by this hashed line here, where we have really tight fit between predicted and measured values. Again, predicted values are in the y-axis. Now let's move over to the messier example right here. I'm just kind of ignoring what these fuel components are here just to give an example. So here we have some predictions in black circles that are all consistently above the line here. And so they actually have a pretty good goodness of fit. They've got a linear relationship with actual values here in this darker line, but they're consistently higher. And so all the model residuals actually would be above what the measured values would be. And so what this calculated region of indifference really does then is give us a sense for model uncertainty. So we have a wide region here which says much higher model uncertainty than the narrow one. And namely that if you use this model, you can expect that your predictions are going to be farther off from reality than they would be in this model. Okay, the third way that we evaluated the models was basically looking at a calculation of model residuals, which is simply the difference between predicted and measured. So a positive residual would be an over-prediction of consumption, and then a negative residual would be an under-prediction of consumption. All right, so coming back to the models, we were able to use our field sample data to populate the model inputs. So for consume and FOFM, a lot of those model inputs are very similar. Pre-burn fuel loads by fuel stratum and category were important. Same with DUF depth, and then fuel moisture by 10-hour fuels, 1,000-hour fuels, and DUF. Consume also required this estimate, post-burn estimate of percent black by the stroke stratum, and then litter depth. But we also need to specify which region we were talking about. So for consume, we specified that we would be using the Southeastern regional equations for the southern pine. Roger already indicated this, but we didn't really have a sufficient set of equations for consume to represent mixed hardwood, so we used the default equations, which are our western pine equations. For FOFM, we specified that the southern pine was in the southeast region and mixed hardwood was in the northeast region. All right, so now I'm going to move into results, and hopefully these plots will look a little familiar based on my introduction. So shrub and herb consumption was adequately predicted by both models. What these plots show basically are the regions of indifference, which represent the model uncertainty. The uncertainty in both of these fuel categories is quite narrow, meaning that it's quite reasonable. Both models predict very reasonable results with low uncertainty. Now we're going to get into the woody fuel by size class. So I'm going to start out with the 1 hour fuels. Once again, we actually had pretty narrow regions of indifference or model uncertainty for both models. However, FOFM has this dashed line for its region, and it shows that there's less uncertainty, and so that you would have more accurate predictions if you were in this fuel type by using the FOFM model. Now, I'll just remind you that Consume predicted 100% consumption for 1 hour, and FOFM used the Burnup model. So a little bit better result, but both of them were pretty accurate. 10 hour gets messier. Consume really overestimated 10 hour fuel consumption in pine sites, whereas FOFM's predictions have no linear relationship between predicted and measured, but even so, you would get pretty close values to actual consumption if you use the FOFM model. So pretty low model uncertainty, even though there's not a linear relationship between predicted and measured. All right, moving on now to larger fuel classes of woody fuels. Neither model did a great job with 100-hour fuel consumption, but FOFM's predictions were more accurate than Consume's. And then both models were pretty comparable for 1,000-hour fuel moisture. There was very low consumption for 1,000-hour, not fuel moisture, sorry, 1,000-hour wood, but and there were also not that many pieces of 1,000-hour wood out there. So that's some of the reason why we didn't have great accuracy in these results. The final fuel category for pine sites that we evaluated was litter. And what we saw here was that FOFM, with its assumption of 100% consumption, consistently over-predicted litter consumption, and Consumes, with its empirical model of litter consumption, consistently under-predicted. They had quite similar regions of indifference or model uncertainty, but FOFM's was a little bit more accurate. Okay. So moving on to mixed hardwood sites, I figured that you probably had your fill of these plots, so I'm just doing all the mixed hardwood sites on one slide. What these basically show for the mixed hardwood sites is a little bit that we didn't have very many sites. We only had 11 sites, and so there's quite a spread in the predicted versus measured plots. Consume did not perform well in mixed hardwoods and had very wide regions of indifference or model uncertainty throughout. FOFM's Burnup model did better, especially in the 100-hour fuels and 1,000-hour fuels. FOFM's prediction of 100% litter consumption was more reasonable than Consume's model. And then Consume did a slightly better job with depth consumption. So what this tells me overall is that we needed more mixed hardwood validation sites, and we also needed a more appropriate model for Consume. Okay, our final evaluation was on model bias. I'm going to start out with the pine sites. In this plot we have again, looking at the model residuals, so it's simply the predicted minus the measured values. And we'll see here that the overall result was that Consume under-predicted consumption. So the total consumption for pine sites was under-predicted by Consume, and that was mostly driven by its under-prediction of litter consumption. So something for us to work on for sure. Slightly over-predicted shrub consumption. And then over on the FOFM side, we had opposite results. So total consumption was somewhat over-predicted, and a lot of that was driven by the assumption that 100% of the litter would consume. So maybe a refinement is needed there. Now moving on to the mixed hardwood sites, Consume did not perform well in mixed hardwood sites. Some of this was due to its way over prediction of 1,000-hour fuels, but you can see that woody fuel consumption was over predicted in all categories, and then it actually under predicted litter consumption by a bit. And then FOFM had more reasonable results, but it didn't fare that well either. Okay, so in summary for the pine sites, putting on my hat as a person that works with managers to recommend whether these models are adequate for their regions, I would say that both Consume and FOFM are adequate. They did a good job for predicting shrub consumption, herbaceous consumption, and 1-hour wood consumption. Consume consistently over-predicted 10-hour wood. FOFM's Burnup model was adequate for sure. Large wood is variable and quite rare in a lot of southeastern pine sites, especially if they're prescribed burn regularly. Both models didn't perform well, and this project suggests that they need refinement. And for litter, models had opposite bias. Consume under-predicted litter consumption, FOFM over-predicted. So given that litter can sometimes be a very large component of pre-burn biomass and result in a lot of smoke emissions, that would be an area for future development. We didn't actually have measurable DUF on our site, so I put an NA there. We didn't measure or evaluate DUF for pine sites. So for mixed hardwood sites, the sites lacked shrub and herbaceous layers, so we did not evaluate those fuel components. We had a low sample size, actually 11 sites, not 12. We knew that we only had the Western equations for Consume, and it didn't really hold water for the mixed hardwood sites. FOFM's Burnup model over-predicted consumption, but had a closer fit, so it would definitely be what we would recommend to managers at this point. I just am going to highlight that improving litter and DUF consumption models is really critical because, once again, in mixed hardwood sites, both litter and DUF are a major fuel component and something to really be concerned about when it comes to smoke management. So for managers, this is really somewhat of a repeat, but we're feeling good about shrub, herb, and 1-hour fuel consumption. We would point managers to FOFM right now for larger wood and litter consumption. The assumption of 100% litter consumption seems like a good one. Then we need some more work on mixed hardwood sites. Next steps. I've been working with others in our team to refine Consume. So this validation data set has certainly pointed us in the right direction. In Consume 4.1, we have the original equations of Consume 3.0, but we expect in the early part of 2014 to have improved woody fuel, litter, and DUF consumption models for southeast pine sites. So we actually need more sites to develop equations specific to mixed hardwoods, but we hope to do that in the future. I just have a couple recommendations for potential refinements for FOFM. I think that it would be great to further evaluate Burnup for application in southern pine and mixed hardwood sites. It's really nice to have this validation study, but I think we might want to look into some calibrations perhaps for those regions. And finally, I just am underscoring the importance of developing really good litter and DUF models specific to eastern forests. Thank you.
Right. Well, thanks, Roger and Susan.
Okay, that's it.
Go ahead, Roger. Sorry.
Well, I was just saying that we're finished with the webinar part, and I guess we can take questions.
Okay. So we have a few questions that have come in so far, and if you're out there and you have a question, go ahead and type it in, and we'll get to it. But while we're waiting for those to come in, we'll work our way through a few that have already come in. Paul, the first one comes from Paul Charland, and he asks, will there be a similar effort to assess emissions from tallgrass prairies or other herbaceous fuels?
Yeah, I can answer that question. One thing about the tallgrass prairie and so forth, we have done some earlier consumption work in the tallgrass prairie, but that work was mainly directed toward emission sampling. And we do have that database, but we haven't really taken that and basically we can't use it as a way to evaluate consume specifically. We could evaluate FOFM, but we couldn't evaluate consume because we used that data to actually develop the equations for grasses in consume. So we would probably want to try to capture another data set so that we could use that for a comparison. Now with regard to FOFM, yeah, we could use that data set to compare and see how FOFM works with those grasses. But knowing that both consume and FOFM generally predict about 90 to 100% of the grasses consumed, they would probably both do a pretty darn good job.
I agree.
Okay. The next question comes from Gary Curcio. Hopefully I got your name right there, Gary. And he asks, were any burns conducted on ground fuels, i.e. organic soil?
For a data set that we showed during this webinar, no. They were all pretty much inland or in upland type sites that didn't have really deep organic layers. Now there's been quite a bit of work, of course, as Gary knows, from the Missoula lab on deep organic soils and like in the Gosen and so forth. And like Susan said, there needs to be additional work to try to figure out what the threshold is when those things catch on fire and burn, and how long they burn and how much they actually will consume.
Okay. Next question from Joe Royce. Hopefully I got your name correct also. The consumption equations percentage from the average is, or I guess, okay, so that's a question. The consumption equations percentage is from the average of measurements?
I think I understand that, yes, in the sense that they're linear regression models, so they're looking for the mean. So I hope that helps.
Okay. And Joe, if that doesn't quite answer, just write back and maybe just clarify a little bit what you're asking there. Next question for Robin Silverstein. It seems consume overpredicts and FOFM underpredicts. Any reasons why?
I think it's a little more complicated than that. I'm going to put in a plug for our Canadian Journal of Forest Research article. I'd be happy to share a copy of that with Robin because the story is a bit more complicated. We certainly go stratum by stratum and go category by category to explain why we think the results happened.
Well, the one thing that Susan also mentioned was that you know, without any other data source for the mixed hardwoods, we just assigned the mixed hardwoods western pine equation. So right at the very beginning, we knew that they probably would not work that well, but that's the best we could do at this point. Now with this information, we can do possibly some modification, but the bigger task is probably to collect more data in the mixed hardwood sites, especially if there's going to be continued burning, if not increased in burning in those particular fuel bed types.
Okay. Pat Brewer wants to know if there's been if a comparison's been done for western forests, or is that still to come?
No, there has not been. The data that we have collected over the years has gone right into building the empirical equations that are in consume. And so you can't use that data to do an evaluation. So there needs to be a new set of data collected to do an evaluation.
Okay. Another question from Gary Curcio. In looking at consumption for surface fuels, are you planning to test or evaluate in using NFDRS? Is there any plans to use or at least look at and validate NFDRS burning index, a tool already in place as a means to estimate consumption for the fire practitioner? More intense work similar to what Scott Goodrick has done.
Well, in reference to Gary's question, right now we have empirical equations in Consume, and they're based on the best input predictors to be able to estimate Consume. And one of the things that we haven't really done is to go back and actually pull up that data and look at the NFDRS predictions and also some other type of indice to see if there's a way that we can use that information. Because mostly what we've done with our equations is develop those equations based on information we collected directly from these prescribed burns and try to relate that to the measured fuel consumption.
Okay. Pat Brewer asks how she can get a copy of the PowerPoints, and I'll say, if you want to get a hold of a copy of the PowerPoint, I would suggest you contact Roger or Susan about that. But we will have a recording of the webinar. It's a Windows media file that'll be available in about an hour, and you can use that as well.
Yeah. Also, both Susan and I don't have any problems with giving out the PowerPoint, so you can just request it from us, and we can send it out to you. And I don't think it's that large. It's like 12 to 15 megabytes, so in most cases we ought to be able just to email it to you.
Okay. Cindy Huber asks, what type of data is needed to do the burnup calibrations?
I went out on a limb and suggested that there might be calibrations, but I know very little about the burnup model and what could be done. So that would need to be a question directed to Bob Keene.
Okay. Gary Curcio has another question. For the next steps, what is being done for the organic soils? They can be 19 to 32 times more potent in the emission reduction over surface fuels. So how will Consume or FOFM take this on in new work?
Well, I think the first thing that needs to be done is to take a look at the literature and get back with some of the folks at the Missoula lab that initiated some early work with these deep organic soils, and then start looking at how we can actually add something into Consume to account for that. Also to take a closer look at the burnup model and see if there's either some type of adjustments to be made, and to see whether burnup could even handle these long-term smoldering situations. So it's definitely back in the ballpark of the modelers to take a closer look at what's already been done and see if we can find something that looks like a logical way to be able to predict this long-term smoldering and consumption.
I'll just add that I really appreciate Gary's continued questioning of this, because I do feel that we need to do a much better job with organic soil consumption.
Now we do have some work we did up in Alaska with deep organic soils during very extreme wildfire situations. So we do have that. Also, the Missoula lab has worked with long-term smoldering up in Alaska, and I know there's a big concern about long-term smoldering in the upper Midwest and some of the Minnesota sites that have huge peat layers also. So it's a big problem, because this, of course, not only produces a lot of particulate matter and other types of smoke compounds, but it can occur for long periods of time, and it's generally low buoyant type smoke that can impact communities for many days, if not many months.
Okay. Joe Royce asks, in Consume, how are the percentage consumptions adjusted with weather variables?
I'm going to come back to the fact that Consume has empirical equations that are based on previous fuel consumption studies. And although we did collect a lot of weather variables in some of those studies, sometimes they were inconsistently collected, or the range under prescription windows was not wide enough to really make them highly significant predictor variables. So oftentimes consumes models are quite simple where pre-burn loading is important and or fuel moisture. But when it comes to the natural fuel consumption equations, there aren't a lot of weather variables that are predictors. We do have some activity fuel consumption equations in which weather does play a more important role. And those activity fuel equations are really most appropriate for logging splash.
Okay. Stephen Maurer wants to know if he asks, weren't research burns done in the Mid-Atlantic region, i.e. New Jersey, a few years ago, and are the results of those included today, or are they still being evaluated?
Well, I'll turn it over to Susan here in a sec, but there has been some fuel consumption work done up in the Pine Barrens area, and that is still being assessed. We haven't put it in the data set, and it maybe because it wasn't available at the time that Susan was doing her literature search. But I have to say that I do appreciate being informed about that, because we definitely need to look at it. The other thing, too, that you have to remember is that even though a lot of these data sets may have had some kind of estimation or measurement of fuel consumption, it doesn't necessarily mean that they collected the right input variables that would allow us for this to become a good evaluation data set. And then also we've got to take a hard look at exactly what was collected and how was it collected to make sure that it is a quality assured data set.
I'll just add that I have asked about the Pine Barrens data set, and I've been in contact with Kim Clark about developing equations specific to them. They're distinct enough that they deserve their own equation sets.
So I guess it's ongoing.
Yes.
That kind of covers the next question as well, so but maybe there's something.
Yeah, I reviewed that one. Yeah.
Yep. So, so Joel just asked, would there be a similar findings with the Pine Barrens in New England, and specifically in regards to the accuracy of the model results? And I think you just addressed that.
You know, that's going to be really interesting to take a look at that, because you know, you are looking at a pine type that does have a good litter layer and so forth, and they burn on a regular basis. So it's going to be really interesting to find out how similar that is as far as comparison with the consumption and so forth we acquired from the southern pine sites.
Okay. And Joe Royce has a clarification on the first question. It says, my first question should have read, are the consumption percentage measures from the average of measurements over the 22 plots on the site? I'm wondering what the internal site variation was.
Yeah, they were. So what we did is the 22 plots, we had consumption measurement for each plot, and then we tallied up the plots and then divided by 22 and came up with an average fuel consumption for each one of the fuel components that we were looking at, which included the you know, the shrubs, the grasses, and the woody fuel by size class, and the litter and duff. And then what we did is we took that consumption for the total unit, and then just divided by the total loading that we found out there, and of everything. It was total loading. It wasn't split up by fuel bed component, just total loading and total consumption, and then we came up with a percentage.
Okay.
We could have got into a lot more detail. I could have broke it up by percentage by fuel bed component, but you know, we'd be here another 2 hours.
Okay. Joe's also wanted to know how to get access to the data set that you guys put together.
That data set is on a repository. It's the CIMIP repository that's housed by the Air Fire team here at the Pacific Wildland Fire Sciences Laboratory. The one thing I'm going to say is that data, I think, is robust enough that I'm working, of course, I'm the principal investigator for the RX Cadre project, which is another project funded by the Joint Fire Science program. And one of the things we are doing is putting that data onto a repository that's going to be housed by the R&D part of the U.S. Forest Service for permanent access. And so at some point we may transfer that data to that repository if it works out really well for the RX cadre. The bottom line is, if you want that data, just contact me and I can send it right to you.
Okay. Another question from Gary Curcio. NFDRS is the only modeled predictor of fuel moistures, and if Consume uses fuel moistures to get at consumption, it makes sense to link the two as does it make sense to link the two as key tools for the practitioner?
Well, I can answer that a couple different ways. First of all, we used to have the NFDRS linked, and the problem is that it was really hard to get the data to Consume. They kept changing the format and stuff back in Kansas City and so forth. And so we decided to pull that out of that. And the other thing that I want to say is that the NFDRS is a National Fire Danger Rating System. That means that when they look at predicting fuel moisture for these different variables or different fuel bed components, they are looking at the worst case scenario. And a good example is if you look at the prediction of the moisture contents for the 1,000-hour fuel moisture or 1,000-hour fuel bed components, it often is down at 30 or 25% or 20%, some cases down to 5%. And if you actually go out and measure that, take woody samples and oven dry them, you'll find that you'll have ranges, from 30 to clear up to 120% of moisture content. So it's fairly under predicts, and there are some equations out there that do just for that. So that could be a possibility. But at this point, to get the best predicting capability of Consume, we suggest that folks go out and actually do some fuel moisture collection if you're really concerned with the duff and the large woody debris. I think with the 10-hour moisture contents and the 100-hour moisture contents and the smaller stuff, you're probably okay with the NFDRS or with fuel sticks.
Okay. Ronald Morrison asks, or he says, it seemed the 10 hours varied the most between models. Why is this?
That's a fun question. I think one of the reasons is that Consume's model for Southeast consumption is an empirical model, and it's simply correlated. The only significant predictor variable was pre-burn loading, so it wasn't sensitive to 10-hour fuel moisture. Whereas BOFM had its Burnup model, which is a physics-based process model, and 10-hour fuel moistures really varied between the sites, so that's my guess.
Okay, well, that was quite a few. That was a very good set of questions, but quite a few, and thank you guys for working your way down the list there. And thank you for a very interesting webinar, very well organized and well presented. It's very clear. Thanks for all that. I want to thank everybody for coming. This webinar has been recorded. If you'd like to pass it on to someone, the link will be on the Advances in Fire Practice webpage soon, or you can email me at joshmcdan@hotmail.com, and I'll send the link to you. We archive all the webinars in the Lessons Learned Center's YouTube channel, and it's easy to access them there and pass it around. So thanks, Roger and Susan. We'll talk to everybody soon.
Yeah, Josh, do they have our emails?
Only if you guys have put them up on the screen.
Oh, we probably didn't, but anybody that's still on, I can just say mine is ROTTMAR at FS as in Forest Service .FED as in Federal .US.
Thanks, everyone. Great
Yeah,
questions.
Thanks. Okay, thanks everybody.